This is What the Hack 15 and our project's demo for the app Heart Hero. Per the American Heart Association, over 500,000 Americans experience a cardiac arrest per year. The standard for life-saving emergency care is prompt access to cardiopulmonary resuscitation, otherwise known as CPR. Our project's goal has been to create a smartphone app that utilizes accelerometer data to train users on proper CPR administration and an at-home setting.
The aim is to have the app monitor for proper rate and depth of compressions by meeting American Heart Association guideline targets and provide real-time feedback to the user. We will dive into the functionality and user interface of the application by simulating chest compressions on a seat cushion. For proper CPR administration, 2 hands are used to deliver compressions. However, for demonstration purposes of the app, 1 hand will be used. We will begin our overview at the main menu screen where all the app functions and toggles are located. The first button from the top allows the user to begin testing chest compressions.
The next button turns on slow mode at 60 compressions per minute for new users that want to practice at a slower rate to get the feel of compressions. The third button turns on a metric screen to show the last 10 compression depths for the user's info. The fourth button navigates to a CPR tutorial, and the fifth button allows the user to view an analysis screen of the last 10 practices.
On the tutorial screen, we see an overview on how to perform compressions and how the app works. The CPR analysis screen allows the user to see the data of the 10 most recent practices and the number and accuracy of those compressions.
Next, we will display the app in action performing compressions at guideline targets and outside of target ranges. Initially, we set a test rate of 95 beats per minute, below the target rate of 100 to 120 beats per minute. We see the app indicates that the user needs to compress faster to get to the target rate. In addition, the phone vibrates if the compressions are off target. When compressing too fast, or above 120 beats per minute, the app results in notifying the user to slow down.
The same is true for compressions with too much force, resulting in feedback for the user to compress less deep. When compressions are too shallow, or less than 2 inches, the app indicates to compress deeper.
Finally, when compressions are performed at the correct rate and depth, the application indicates that the user is compressing appropriately. If the user deviates from this, the application will provide feedback again for correction.
Deeper, good compression. Deeper, good compression. Deeper, good compression.
At the end of the practice session, we're able to see the number of and percentage of accurate compressions. When reviewing the CPR analysis screen, the user can view their past performances and how they have improved.
Next, we see the user toggle on slow mode, which is meant to help new users become more comfortable with performing compressions at a slower rate. The colored circles fall at half the rate, but feedback is still given in real time.
Less deep, good compression.
Finally, the user can enable last 10 depths mode, in which the user is periodically presented with the depths of the past 10 compressions.
Less deep, less deep, less deep, good compression.
Reflecting on the app creation process, it is interesting to observe how many of the topics learned in lecture were applied to solve the challenges encountered during the different phases of app creation. Examples range from incorporating the activity recognition chain for detection of compression cycles, utilizing location methodologies such as dead reckoning for compression distance, and implementation of fast prototyping and design for the production of the app UI and functionalities. Changes to the original plan were minimal. However, testing on a certified electronic CPR mannequin, such as those provided by the Red Cross, was unable to be performed due to logistical reasons. Moving forward, this would be the next step to tackle, in addition to communicating with emergency responders and other healthcare professionals to explore the features they would find beneficial. Overall, the app achieves the team's primary goal of providing the public a method of training CPR compressions at an in-home setting.